Hello. In this short video, I'm going to highlight the test feature, how to select the right model for a given working substance. Well, the thermodynamic model developments are done in chapters 3 and 11 and 12 in your textbook, and also in chapter 14 actually. So there is a lot of knowledge, a background that is required to understand any model thoroughly. But essentially, a model is a set of assumptions. Uh, so, but to simplify, when you have to handle a solid or a liquid that you know stays solid and stays liquid in a given problem, say a pump, pumping liquid water, then use the SL model, the simplest model. If there's a possibility of vapor-liquid transformation, use the PC model, like in a steam power plant, for example. And the gas model has perfect gas model, ideal gas model, and real gas model. Real gas is actually not necessarily a gas model. It's for fluids for which you don't have data. So it's generalized, it uses generalized tables. And for accurate results, you should not be using real gas model. So it's either perfect gas or ideal gas model for a gas. Ideal gas means the Cp and Cv are variables, and Pg means Cp and Cv are constant. That's the only difference between these two gas models. Similarly, a mixture model could be, gas mixture model could be two different perfect gases, two different ideal gases, or a number of perfect gases or a number of ideal gases. These are called NPG and NIG model. A moist air is a special perfect gas and perfect gas model. Water vapor and dry air are considered perfect gases. We call it the MA model. And finally, there's the sophisticated NIGE model where you allow equilibrium to take place. Suppose you put air at a very, very high temperature. Obviously, oxygen and nitrogen may dissociate, so it handles those kind of tough situation. So let me just quickly go and show you in the perspective of test steps. The last step is always selecting the particular model. As you can see, the models are kind of logically ordered here. All the gas branch is this side, gas mixture is on that side, and you can see the PC model occupies here. Well, just to give you a specific example, suppose you want to solve a steam power or a gas turbine problem. You follow the specific branch and you click on this node and look at the models available to you. There is a good chance that you probably are going to use the PC model for vapor power plants, or ideal gas or the perfect gas model for gas turbines. All the other models that are supplied are for specific situation, like in a combined cycle, there may be two different PC fluid. There could be, in a topping cycle and bottom cycle in case of a gas turbine on top of a steam turbine. Anyways, once you launch the app, suppose you want to solve it for vapor power here, you click here. The hands-on example page sometimes combine different things. So you got to search for a problem where you find the vapor power plant and make sure, yeah, right there, we can see the vapor power plant. You can find the test code, and you can find a video of a particular solution, for example. And you can see that the model selected, if you follow the path of a test step, you will find the model is the last node of this path. So you will find plenty of examples in addition to examples page on the test step page. So you go to the test step to launch test steps. But in addition to these examples, you can also go and browse in the problem section and isolate, for instance, steam power plant, and isolate some examples by clicking these example buttons. And over there also you'll find test codes. Not a video solution for each problem, but at least detailed manual. It's called unrestricted solution. You can go and see the manual solution, you can see the test solution, etc.